Okay, this video is designed to cover all of the major concepts related to rectilinear motion, which is motion in one dimension. Position is just that. It's where an object is at a given moment in time compared with the 0 meter mark. So if I'm at 2 meters, my position is 2 meters. We typically use the variable s to represent position at a given time. Sometimes the variable x is used as well. Velocity, by definition, is the change in position over the change in time. So we subtract our two positions and divide by the change in the time over that position, and that gives us our average velocity. Now, if we want to find instantaneous velocity, what we need to do is we need to take an average velocity over a small interval. In other words, we need to make, for example, if I wanted to know my instantaneous velocity at time 1, I would have to take a secant slope where time 2 was close to time 1. And that's the idea of a limit. So we're going to let t2 approach our time of interest, which I'm just calling t here. The limit of my average velocity will give me my instantaneous velocity, which I've got denoted v of t. And you'll note that this limit looks familiar. It's the limit for the derivative of this function. So s prime of t is therefore the same as instantaneous velocity. Now we also know that when a derivative is positive, in other words, when a velocity is positive, this function, s, would be increasing. In other words, a positive velocity tells us that the particle is moving in a positive direction. It's moving to the right if we're moving left and right. If the velocity is negative, s prime is negative, and if a derivative is negative, then the function whose change is being described is decreasing, and therefore the particle is moving towards the left. Alright, don't confuse speed with velocity. Velocity can be positive or negative depending on the direction we're moving, whether position is increasing or decreasing. Speed is always a positive quantity. Speed is defined as the absolute value of instantaneous velocity. So acceleration is the change in velocity over the change in time by definition. And this calculation will give us average acceleration. So just like with velocity, if we take the limit of this expression, if we make t2 approach t1, if we take an average acceleration over a smaller and smaller interval, we will get approach an instantaneous acceleration. So the limit of an average acceleration gives us an instantaneous acceleration. And since this expression represents the derivative of v, so since this expression is v prime of t, we see therefore that v prime of t is the instantaneous acceleration. And just connecting that to position, that would mean that the second derivative of position is equal to the derivative of velocity is equal to the acceleration. So that's how these three concepts are all connected via calculus. And once again, if a derivative is positive, if acceleration is positive, which means v prime of t is positive, it means that velocity is increasing. If acceleration, v prime of t, is negative, then that function that's being described, whose change is being described, is decreasing. Now there's an important relationship between velocity and acceleration. Remembering acceleration is the change in velocity over the change in time. So let's just take a look at that. If we are traveling at a velocity of 10 meters per second, keeping in mind that a positive velocity means that position is increasing, so my particle is moving towards the right. And my acceleration is positive here. My change in velocity, which is what acceleration is 2 meters per second every second. So after 1 second, we'll be going at 12 meters per second. After 2 seconds, we'll be going at 14 meters per second, etc. You can see that my speed, which is the positive of velocity, is increasing. So in this case, we are speeding up. take a look now where we have a positive velocity. Again, the particle's moving towards the right, but our change in velocity is negative. Our acceleration is negative, which means we're dropping 2 meters per second every second. So after 1 second, my velocity is 8 meters per second. After 2 seconds, drops another 2 meters per second. My velocity would be 6 meters per second, etc., etc. And you can see then, since speed is the absolute value of velocity, that we are slowing down. Okay, let's look at the situation where we have a negative velocity, which means position is decreasing, the particle is moving towards the left, and my acceleration is positive, which means my velocity is increasing at 2 meters per second every second. Well, if my velocity is increasing, after 1 second, we'd be at negative 8 meters per second. After 2 seconds, we'd be at negative 6 meters per second. After 3 seconds, we'd be at negative 4 meters per second. And since speed is the positive of velocity, you can see that my speed is dropping. I'm slowing down. And the last situation is when velocity and acceleration are both negative. Negative 10 meters per second. We're moving in the negative direction. We're moving left. And our velocity is changing. Our acceleration is negative, so our velocity is changing at negative 2 meters per second every second. So after 1 second, we're negative 2 meters per second lower, so we're at negative 12 meters per second, and we're at negative 14 meters per second, and since speed is positive of velocity, we can see that we're speeding up. Alright, so the point I want you to notice is that if acceleration and velocity have opposite signs, we're slowing down. If acceleration and velocity have the same sign, we're speeding up. Alright, let's put all of these concepts together by analyzing this situation. We have a particle which is moving along a line, and we'll say that S is measured in meters. This is our position, and our T is measured in seconds. Okay, and we have the position at time T represented by this equation. Now, in our analysis, we're going to want to look at velocity and acceleration. So let's get the velocity out here. The velocity is the derivative of position. And my acceleration, which is my derivative of velocity, is 6t minus 12. So the velocity is 0. And I'm going to solve this equation. I'm going to do that through factoring. When t is 3 or t is 1, the velocity is 0. The acceleration is 0 when t is 2. Alright, let's look at where the velocity is positive or negative. Now, the reason we want to do that is that we know that the sign of the velocity, which is the sign of the first derivative, tells us the effect on S, the position, whether it is increasing or decreasing, therefore whether the particle is moving left or moving right. So at 1 and 3 we've got velocities of 0. Okay, so my velocities are 0 and 0 here. And since I know the shape of my velocity graph, which is a parabola opening up, I can quickly see that this is my velocity function. I got a positive velocity, negative, positive. I therefore know that my position is increasing, decreasing, and increasing. So the particle is moving to the right, then it's moving to the left because position is decreasing, then the particle is moving to the right. Let's next move to acceleration. So my acceleration was at time equals 2. By the way, in this question, it only told us to look at time greater than 0. So really, I don't need to look past time 0 here. Okay. All right, so let's now look at my acceleration. I want to look at the sign of acceleration, which is the sign of the first derivative, because that tells me the effect on velocity, whether velocity is increasing or decreasing. Alright, and since I know the shape of my acceleration graph, which is a line moving, opening up, I know that my acceleration here is negative. At 2 it was 0, and here it was positive. So when my acceleration is negative, I know that velocity is decreasing. When acceleration is positive, I know that velocity is increasing. Now I can take the information that I have about velocity and acceleration, put them together. So I'm just lining up my points from above where the velocity and acceleration were 0. And in situations where I have opposite signs, I know that the particle is slowing down. When velocity and acceleration have the same sign, I know I'm speeding up. Slow down. Both positive, speed up. Alright, so what I have here is I have a number line showing the position of my particle at a given moment in time. And what I've done is I've calculated the position at 0, 1, 2, up to 5 seconds by simply plugging in the times at those moments in time into this equation to generate these values. So at the 0 second mark, my particle is at the 1 meter mark. At 1 second, we're at the 5 meter mark. Now you remember that at the 1 second mark, that was when my velocity was 0. And from the number line on the previous page, the particle changed from moving right to moving left. So that's how I'm showing my position. At time 2, t equals 2 turned out to be the place where the acceleration changed. So we had a transition from speeding up to slowing down right there. Okay, when the particle was at the 3 meter mark. So this point right here is when time is equal to 2. Time is equal to 3 was another place where the velocity was 0 when the particle changed direction. And then after that, the particle kept moving to the right. And I can see my position. Alright, two final concepts to talk about. The first one is displacement. And displacement is just the change in position. So it's the position at the ending mark minus the positioning at the beginning, which in this case would be 21 meters minus 1 meter, which would be 20 meters. Alright, when I do my total distance traveled, I have to take into account the fact that this particle changed directions twice. It changed direction at time 1 and at time 3. So what I'm going to need to do is I'm going to need to define the displacement of each of these sections, make them positive because distance is a positive quantity, and then add them all together. So I need the displacement between 1 and 0. I'm going to absolute value that because I need to ensure that that's a positive quantity. The displacement between 3 seconds and 1 second, absolute value that to make sure it's positive, and the same thing between 5 and 3 seconds. Alright, substituting my numbers in. So this would be 4, this would be 4, and this would be 20, and so my total distance traveled is 28 meters.